I'm Shay Payne from Discovery School.
And I am Caleb Jones from Overall Creek.
So, quick shout out to the Payne's peeps. Hey guys.
Morning, Jones's geniuses.
Well, how was your spring break, Mr. Jones?
You know, it wasn't horrible, but we didn't get to go on our cruise. You know, there's the big water slide. I was ready to go. I had my swim trunks ready, my Hawaiian shirt. I really missed it. I wanted to do it. Really
I missed my beach vacation. You know, we're in this big historic time and this global pandemic, and it's something kids are going to be reading about years and years from now, but we're kind of living it right now.
Yeah.
So what do you think we could do instead of being sad about missing those vacations?
Well, once this is all over, I have an idea.
Okay.
Why don't we take a trip down the Stones River in the kayak? What do you think?
Just you?
I could sit, I could sit here and you could sit here, or maybe you sit here.
No way. Okay. I've had just a few M&Ms over the quarantine time. Are you sure that you're gonna sit where?
Oh, come to think of it, I haven't been to the gym either. Man. I don't know if that's
Do you think we might have something that we could share with our students that can talk a little bit more about floating?
You know, we might have it. Let's read a book and find out about these animals that think that they can pile into a boat.
Okay.
Let's see if we can do that, like the animals. I don't know. All right, so Who Sank the Boat by Pamela Allen. Beside the sea on Mr. Pepper's place, there lived a cow, a donkey, a sheep, a pig, and a tiny little mouse. They were good friends, and one warm, sunny morning, for no particular reason, they decided to go for a row in the bay. Do you know who sank the boat?
Okay, well, I'm going to go with that cow because I cannot see a cow in a boat.
Well, he is pretty big, but you know, he's the first one in, so I don't know, Miss Payne. He's the first one into the boat, and, you know, I'm not so sure he will sink the boat. Let's find out.
Okay.
Was it the cow who almost fell in when she tilted the boat and made such a din?
See, she's tilting the boat already.
Oh, well, you think so? Let's find out.
That looks pretty sketchy.
Whoa! No, it wasn't the cow who almost fell in. Do you know who sank the boat?
What? The cow didn't sink the boat? Okay, well, who's up next?
I think it's a donkey.
Okay, wait, a donkey and a cow in a tiny rowboat.
Hey.
They're going down. I'm going to say the donkey's going to sink the boat.
You think so? He does look kind of clumsy. Maybe, I don't know. Let's see. Was it the donkey? Oh, who balanced her weight?
Ooh. Oh, I didn't think about balancing her weight. Wonder if that makes a difference.
To balance her weight. Who yelled, "I'll get it into the bow before it's too late."
Oh, she did a really good job of balancing her way in.
What a graceful donkey. 2 hooves down, side by side, all balanced. No, it wasn't the donkey who balanced her weight.
So we have a cow and a donkey in a tiny little rowboat. I just don't think this is going to go well.
Well, let's see.
If they put anything else in this boat, it's going down.
You think
anything
so?
else goes in this boat, it's going to sink.
Well, they are awfully balanced, and, you know, the clumsy cow did manage.
Do you think you and I could balance this canoe?
I don't know.
The Stones River is really cold right now, and I don't care to be cold.
Well, we'll find out. It wasn't the donkey who balanced her weight. Do you know who sank the boat? Look at that.
They're doing a good job.
Was it the pig as fat as butter who stepped in at the side and caused a great flutter?
Okay. Pig, donkey, cow, in a tiny rowboat.
All pretty big animals.
They're pretty big animals.
Oh, wow. Look at that pig is going to tilt that boat.
That's it.
You've got the donkey and the cow on the side. That pig's holding on for dear life. They're off. But it wasn't the pig. No, it wasn't the pig as fat as butter. Do you know who sank the boat? What do we have left?
Okay, so if I remember correctly, we had a pig, right?
We had a pig.
We got the pig in the boat.
Yep, and I think donkey was on one side.
And then cow's on the other.
And cow was on the other, so now we have
left sheep and the mouse.
And the mouse.
Well, it's not this mouse. There's no way that mouse is sinking that
Right?
boat.
Little bitty mouse.
Little bitty mouse. If they've got this under control, although I will say, unless this pig is sitting here in the middle, that whole balance idea might be off.
Not as balanced.
So I'm going with the sheep. The sheep is definitely going to sink the boat.
Wow. I like your prediction, Miss Payne. Let's find out. Was it the sheep who knew where to sit to level the boat so that she could knit? Aw, look.
She's getting in pretty easy.
Yeah. No, it wasn't the sheep who knew where to sit. Do you know who sank the boat? There's the sheep. It's looking balanced in our boat. Do you think their boat was balanced?
Well, this boat looks pretty balanced.
Right.
But I will have to say that the boat in the book looks a little smaller than our boat. So I think if you and I got on this kayak back here, it'd be a lot like the cow and the donkey, and it would go down.
Well.
So we definitely
not.
probably couldn't take any more room. But I just don't feel like it could be this teeny tiny little mouse who actually takes this boat down.
Maybe it was a trick the author was trying to play on us, you know?
Maybe.
I
I
hate when
don't
that
know.
happens, but it could.
Let's see what happens. It's a pretty cute little picture of them balancing in the boat nicely.
What do you notice about that boat, though, Miss Payne?
That boat looks really low in the water.
Yeah, it's submerged in the water further and further as we read.
Every time that we read, and look how close that water is to just lapping over the side.
Yeah,
And
this
I
isn't
feel
looking
like once that water gets a little higher,
good. If it gets in the boat, it's going down.
that's it.
Was it the little mouse, the last to get in, who was lightest of all? Could it be him?
Here we go.
In leaps the mouse.
Oh, look at the boat. Look at how close to the water the boat is.
Wow.
Oh, man, I would have never guessed it would have been that mouse.
Do you think it is? It hasn't gone in yet, but it did. You do know who sank the boat.
Oh.
And Splash, look at him.
My
Look at that
goodness.
mouse, Miss Payne. Did you know
Wait, he's the only one that gets wet, doesn't get wet. Go
So
figure.
can we blame him? He didn't even get in the boat.
He didn't even get in the boat.
But what did he do? Look how
Well, he obviously sank the boat.
he sank the
and they're all
boat.
soaking wet.
They're all drenched. And there's the mouse, living his best life, as happy as can be.
All right. Okay, so we've got kind of an interesting idea here. So what we want to think about is when we think about this boat and all of these animals, let's go ahead and put our little mousy friend here. And when we think about this boat and all of these animals, we have a couple of things at play here. So we have two guiding questions today that we're going to kind of guide our lesson here. So the first question, and I think we have a slide for this, but the first question is, what caused the boat to sink? We want to focus on what caused the boat to sink. So did the length, height, and weight of the animals,
Or could it have been the boat?
or could it have been the shape or size of the boat?
Mm-hmm.
Okay. All right. So when we think about, let's go back to your cruise, right? So you were going to go on this big cruise. And so what do you know about cruise ships?
Well, cruise ships are really large. There's a lot of space.
Okay.
There's a big cavity inside of a cruise ship that holds air
Okay.
and people. So
And our boat, what's our boat made out of?
our boat's made out of wood.
Okay, so wood, we can, a lot
It's
of
not
times
very
wood,
dense.
I know that when I've been floating down the river or when I've been to the lake, I can see logs that kind of float along beside the boat as we go along. So I know that wood can float, but I don't think that cruise ships are made of wood anymore. So like I know way back in the day when the Spanish and the English were sailing over to America, they had wooden boats. But do we still use wooden boats today as cruise ships?
Not as cruise ships, to my knowledge.
Okay.
No,
So what do you think cruise ships are made out of?
they are made of metal usually.
Okay. But does that metal typically sink?
Well, it depends on the type.
Okay. So as we think about these guiding questions, we really want to think about, did the length, height, and weight of the animals themselves here cause that boat to sink?
Right.
Or did the shape and the size of the boat? So we're looking at a couple of things. So length, weight, height of the animals.
Wait a minute. So weight, I remember weight is one of those things that has a force of gravity. Is that right?
That's right.
So what about mass? Do you think that might help us?
Okay.
I'm wondering.
So weight is going to be the gravitational pull on an object, okay? And your mass is a little different from that, right? The mass is the matter contained within an object.
What is mass? I'm wondering if we have a definition for that.
So, look at that. Is a measure of how much stuff or matter is in an object or a substance. Okay, so we have a lot of stuff and matter in our boat here.
So you mean to tell me that there's more matter or mass in this than this?
I think so. I mean, I know what I know about donkeys and mice are, and I've seen some pretty big rats, but I've never seen a rat as big as a donkey.
Right?
This is massive.
And not as massive.
And not as massive.
Okay.
Very good. Okay. All right, so we have a little at-home experiment, and I'm really excited about this because my fourth graders, we do this at school when we talk about density, or we have in the past. And so we have created just from things that you can get in your kitchen at home and in your pantry, we have created some experiments here.
I love that. Is that a density column?
These are density columns.
Whoa.
And we have just used standard everyday things that you can find in your house. And this one over here is just a little bit more, it has some more things in it, so it has more layers to it. So you really could experiment with lots of different fluids in your house, liquids in your house, and to see which ones float and which ones sink. But we're going to do our experiment today on this jar. So this jar has 3 fluids in it. Can you guess what they are?
Well, one looks clear at the bottom, so I'm going to guess there's some water.
Okay, there is water in there.
There is water in there, and then one looks really blue liquid. I don't know, really a thick-looking liquid. I'm going to call that corn syrup, and then olive oil.
Ooh, good job. That's right. So there is olive oil, corn syrup, and water in this jar. So this jar here has several other things in it. So at the very bottom, it has corn syrup, and then it has a layer of honey. And I will tell you a little fun fact, that if you leave corn syrup and honey together, they will start to kind of mix together. But when you very first put them in the jar, if you're very careful to pour them in, you can see them separate. But over time, they are going to
separate? Because I was thinking that you had some kind of like sheet, maybe a plastic sheet between these layers.
And you know how I can prove that to you? Is that I can take this jar and I can move it like this and this, and that proves that there's and if you looked really closely, you could see those fluids.
No sheet between them.
No plastic sheet between them.
So how does that happen?
So that goes back to density. So each of these liquids has a different density than the other one.
That's fancy. You'll have to learn more about that. I wonder
and density can be a really hard thing to think about. So when we think about that, we want to think about those molecules that are really tightly packed together. So things that are more dense or have a lot of density, I think we have a slide that shows that, have molecules that are really tightly packed together.
Yes. So like a molecule in a rock is more dense than a molecule in the wood.
Yes,
so
they're
that
really
means
tightly packed together.
Tightly packed molecules. And then, so the molecules in wood are less dense because the molecules are less tightly packed together.
Very good, so that might explain why wood is a better...
So liquids have a density too.
Liquids do have a density.
Do these liquids have a density?
These liquids do.
What are the densities of these
so
liquids?
this very bottom liquid right here is going to be corn syrup.
Okay.
And so this is just light, clear colored corn syrup, and it's kind of like the syrup that you put on your pancakes, but it's a lot thicker. So this is the kind of syrup they use to make candy. So this is corn syrup. So what would you say the density
of that corn syrup is?
So the density of the corn syrup is actually 1 and 3300 grams per milliliter. Do you know how we figure density?
No. What's that?
Well, we have a formula that we use to figure density. And so you take the mass of the substance, and you divide it by the volume, and that gives you density.
Okay, but like liquids is found the same way, but we don't have time to get into that. So So water is the standard. It's like the benchmark.
Yeah.
So 1.00 grams per milliliter for water. And I noticed that it is actually less dense than the corn syrup.
That's correct.
Which is why it sits in the middle.
Absolutely.
But it's more dense than olive oil.
Yes, absolutely.
Okay, because olive oil, 0.92 grams per milliliter.
Yeah. And you notice how close olive oil is to water?
Oh.
And that's because if you've ever put oil and water together and you shake them up, they will mix for just a little bit, but then they'll separate out. Okay, so let's get back to our experiment, our kitchen experiment that we've done here. So we have these different densities of liquids, and so we have our corn syrup at the bottom, we have our water in the middle, and then we have our olive oil at the top. And then I have a couple of objects, and so what we really want to see, because we're going back to those questions that we're talking about. So is it the size, the weight, the height of the animals that caused the boat to sink? Or is it the size and the shape of the boat that caused it to sink? So when we think about that, we want to think about objects. And so we're thinking about density, and we're thinking about the mass that's contained within an object. So we have some objects here, okay? So well, first of all, do you know how you figure volume?
Well, volume of a regular solid, when I was in school, I learned length times width times height.
Yeah, length times width times height, right? So length times width times height. Yeah, and that's going to give you the volume of a regular solid. But what do you do when you're trying to find the volume
You're trying to trick
of an
me.
irregular solid?
You've got this pretty cool thing here. I think, is that graduated cylinder?
This is a graduated cylinder because it gradually increases
How
as we
much
go up
water
there.
do you have in there?
I have 60 milliliters of water in here. And so our little marker, this is a great graduated cylinder.
I like how you're
that
measuring
MCS
precisely.
let us borrow. Thank you so
Yes.
much. And so this will mark that 60 milliliters. And I know on camera this is kind of hard to see, so you'll just have to take our word for it. So we are going to use a neat little trick to show you how to find the volume of an irregular solid. So I'm going to take this rock. Now I want to be really, really careful because I do not want to drop this in there. Do you know why? Can you think why?
Well, water is not so dense, so
That's true.
it's going to splash out if you throw it in there.
Very
You better
good.
be careful.
And this is
Good
also
idea.
glass.
Glass, that
Yeah.
breaks.
So when we do this, we want to slide this rock in just like this. And then look at there.
Did that go up by
It
5
did.
milliliters?
It went up from 60 to 65 milliliters.
Hmm.
So if we take 65 and we subtract 60, what do we get?
5 milliliters. Miss
That is
Payne.
exactly
The
right.
volume of the rock.
Yes, so that is correct. So we are going to take our rock out
Yeah.
and
Little splash on the towel.
little splash
bit.
on the
Just a
towel,
little
just
bit.
a little. And we're going to take our rock out, and then we are going to see. We also have a piece of cork, and cork is usually a natural product, but this one is synthetic. Most cork nowadays is synthetic.
Good to know.
And then we have just a regular old thumbtack. Okay, so these are all things that you can find around your house. And then you can experiment with other things too, right? You might try a chocolate chip or a paper clip
That
or
sounds
something
fun.
like that.
I'll have to do that right
Okay,
now.
all right, so now I want you to very quickly make some predictions. Which one has the least density?
The least density.
So we have a rock, a piece of cork, and a thumbtack. Which one has
least
the
dense.
least density?
Well, I kind of think that I think this one has the least density.
Okay, so
It's
you
small.
think
I know they're light because I use them in my
Okay.
classroom all the
Okay.
time. So it's really small. I know it's really light. So I'm making my prediction that
okay,
will
so
be
you
the
think
least
this
dense.
thumbtack is going to be the least dense? Okay, all right. So let's find out. Okay, so we're going to go ahead and drop our rock in. Are we ready? Okay. Have you made your predictions at home? Which one's going in? Here you go. Here goes the rock.
All the way to the bottom, like the Stones
All the
River.
way to the bottom, just like the Stones River.
All those rocks down there. You never see
Yeah.
rocks floating on top
That's
of the water.
right. That's a good point. Good point. Okay, and then we're going to try, since you said that this one was the least dense, we're going to try the cork next. Okay, so here's our cork. And, oh, it
Well, it's
floats
moving.
right on top there.
Huh, but it's not going in. Wonder. Interesting.
Yeah,
So
floating
if
right on
the
top.
oil had a density of 0.92, that tells me that the density of the cork is less than oil.
Very good. And since you're on that, what about the rock?
Well,
it went straight to the bottom.
It has to be greater than 1.33.
You got it.
Greater than the corn syrup,
Okay,
right?
and so we're going to figure that out in just a second. So I'm glad you said that. Okay,
Exciting.
here's your guess. You said
I think that's going to be friends with the corn. They're going to hang out right here,
right
side
here
by
at the
side.
top. All right, here we go. Ready?
Ready. Wait, is it trapped?
Oh, can you see it?
Yeah, it's in the middle.
Can you see it? It is hanging out.
It wants to go down into the corn syrup.
Oh, there it goes just a little bit.
A little bit.
And it does look like it's sitting on top of that rock, but it is
Wow.
actually not.
Interesting.
Yeah.
So
we have a really interesting little phenomenon with that tack.
yeah, it didn't stay on the top like I had predicted. Why is that?
Okay, so it has to be more dense than the olive oil.
Okay.
Right, so we said the olive oil had a density of 92 hundredths grams per milliliter.
So
right?
it has to be greater than
Right,
that.
so it's got to be greater than 92 hundredths grams per milliliter.
Yeah.
All right, and then water is 1 gram per milliliter, right?
Yeah.
And then the corn syrup was 1 and 33 hundredths grams per milliliter, correct?
Yes.
Okay, so when we see that a little bit of this tack is in that corn syrup, why do you think that is? What's the tack made out of?
The tack is made out of a metal, but a lot of it is also plastic.
Yes, and so that gives it a
little fluctuation in its density, doesn't it?
It absolutely does. So it's not an
Huh.
actual true floater in the middle, right?
Right.
And so it has a little bit of density.
That's pretty cool. I like
Yeah,
chemistry.
I
This is
do.
awesome.
I do too. Okay, so we have, when we talked about our equation for density.
Density equals mass divided by volume.
Very
It's a
good.
ratio of the mass per unit volume.
That's right. So all those sixth graders out there that are learning about ratios.
Yep, check it out.
This is a ratio. So this particular so let's just use the rock, okay? So because we figured the volume of the rock, right? Which, do you remember what it was?
The volume of the rock was 5 milliliters.
Yeah. So the volume of the rock was 5 milliliters. And so what was do you know the mass of the rock?
The mass, I think I used the kitchen scale. It said 7 grams, did it not?
7 grams, it
Okay,
did.
so
Yeah.
7 divided by 5 is 1.4 grams per milliliter.
That's correct. All
Which
right,
is
so now let's make some connections.
interesting.
So the corn syrup was how much?
1.33 grams per milliliter.
Okay, so if the corn syrup was 1 and 33 hundredths grams per milliliter, and the rock was 1.4 grams per milliliter, 1 and 4/10 grams per
more than
milliliter.
1.33. That makes sense.
That's the reason that
Yes, I'm going to give you a quarantine high five from all the way over here. You got that right. Good job, Miss Payne.
All
That
right.
was awesome.
Okay, so let's go back to our guiding questions. So you want to give us our guiding questions again?
What caused the boat to sink? Well, this boat had a density, right? It has to. It had a density, and if density is mass over volume, or mass divided by volume, the volume of this didn't change, but what changed was the mass that was applied to the boat as we added animals.
Yes.
You know, and so the extra mass that we added to the boat caused the density to increase. Volume was constant, mass increased, it did, and so that makes the density increase, which then, I'm guessing, the density of the boat was greater than 1, right?
Yeah.
And down it went.
Okay, yes, so you're absolutely right. So when the boat was floating,
Yep.
the density of the boat must have been less than
Water.
water. Yeah, it was less than 1. So as we think about that, when we increase the mass, therefore the density went up, and that's what sank the boat.
And you know what I heard?
What?
I heard that the density could decrease if you increase the volume and let the mass alone.
Well, that makes perfect
Isn't that
sense.
cool?
Going back to your cruise ship. Because think about all of those people and all of that amazing food. And oh my gosh, that slide that you were talking about.
Ah.
Think about how much mass that's got to be on that boat. So they have to make those cruise ships gigantic.
Speaking of boats, I think we better get a canoe. Do you know? I think we
'cause
better.
I'm not going
That's not going to work. I think we need something with a volume
I'll
that'll
go by
support our mass.
myself.
Okay. Well,
Make sure I got my
can
life
share. I'll
jacket
share
on,
the
right?
kayak with you, Miss Payne. You're pretty cool.
No. We're going to have to go in a canoe, but my husband says I'm not a very good balancer.
Oh, really? You'll
Yeah.
have to practice at home in the bathtub.
Yeah, I'll have to definitely do that. All right, so let's kind of recap real quickly. So we've learned about what today?
We learned about density.
We did learn about density, very good, and we came up with a really cool home experiment, right? And then we talked about how we can use different fluids in our house to create these density columns. I loved your label for that, so a density column. That was very cool. And you could also experiment with, since we talked about changing the volume of the vessel, since your liquids are going to conform to whatever container you put them in, you could try different containers. So would that look different if I put it in a graduated cylinder? Yeah. If your mom has a cool vase at home that she doesn't mind you using with handling with care, you might try something like that.
Okay. And you know, speaking of liquids and measuring, I like how you measure precisely today when you use the graduated cylinder. Good idea.
Yes. How could you measure precisely in your kitchen?
In your kitchen? Well, I'm sure moms and dads and grandmothers have those measuring cups.
Measuring cups and measuring spoons. Yeah. So you could use that to make sure that you have, if you're trying to figure out, if you're trying to use one of the formulas that we talked about, you're trying to use volume, which was times width times height, or that was for a regular solid. For an irregular solid, you could put it in a graduated cylinder, and you could check the water displacement. And I don't think we actually said that, but that's what that's called, is the water displacement. So when that rose 5 milliliters, the water was displaced 5 milliliters. And so then you could try that with different fluids. And like I said, on this jar over here, this one has a lot more fluids in it. So this one has honey at the very bottom. So honey is super duper thick. And then corn syrup. And then this one has dish soap in it.
Okay. Did you put food coloring in those too?
I did not. Okay. I did not put. Oh, you know, the only thing I put food coloring in for this one was. Oh nope, I don't have any food coloring in this one at all.
That's really beautiful.
They just really turned out. Yeah, it's like a sunset, isn't it?
That.
Oh, it reminds me of the beach.
So there are a few other things that you might check out at home if you're interested. We've got a penny boat, is what it's called, on our last slide.
Ooh, this is a fun one to make at home. We do this one in Science Olympiad. And so you make a penny boat. So I think we have a slide for this one, if we want to show that.
Yeah, so pbskids.org has penny boats that you can make out of aluminum foil. That's all you have to have. So you can float pennies on that.
You can see how many pennies you can get in it.
Yeah.
You could even compete with your brothers and sisters to see who can get the most pennies in their boat. Okay.
That would be a lot of fun, wouldn't it?
Yeah.
We're going to have to try that out. Brain Pop Jr. has a sink or float. There's also more on Brain Pop for that. And then EasyScienceForKids.com for some more fun facts on today's learning.
All right.
Thank you, guys. This has been awesome.
It's been so much fun. Another quarantine high five. Thanks. Bye, Pete.
Bye.
See ya.